Thank you, Amy. Just give me a second here while I open this file. I'll just say that one of the joys of being an architect and a landscape architect is that I get to pay dues to both the AIA and the ASLA. And we have a 12-person office. We're at 23rd and Mission. A lot of those people are here tonight. Let me see if I can get this up. So I want to thank my staff first, just for coming out, because a lot of the work you're going to see tonight is theirs, and as everybody here knows, it definitely takes a whole team. So our most recognizable project is the Exploratorium, and we worked on 2 acres of outdoor space on the waterfront there. And if there's anything I learned in this 15-year association with the Exploratorium, is that everything that you see over there, all the most creative things, come about from two methods, mostly observation and trial and error. And so I thought that'd be a really good place to start with a discussion of concrete, because I don't think you have to do calculations or be an engineer or be particularly sophisticated in order to be a really good designer with concrete. Another observation, my first observation, is that as urban densification has become more intense, that commissions for landscape architects has shifted from suburban commissions like parks and plantings and flat work and so on to projects that focus on infrastructure and projects that are much more urban and more highly detailed. So as landscape architecture has become more sophisticated with architecture and engineering, I think architecture has also become more aware of environmental principles, and that consequently there's a much bigger area of overlap between architecture and landscape. And so I really like this project, the Seattle Art Museum, because it's this really wonderful combination of architecture, landscape, engineering, and infrastructure all woven together to connect Seattle's downtown to its waterfront. So this is not so much a new idea, but it's really reclaiming an old idea. And so I'm going to start with this image. It's a Piranesi etching from the 1700s. This is Piranesi reimagining the aqueducts of Rome, coming into the city. And again, you have this combination of architecture, landscape, infrastructure, all conspiring to make this wonderful public space. So many of these structures from Rome are made out of concrete. And the concrete is in the core of these structures, and then they're often faced with brick or stone or travertine. So this is an aqueduct still standing after 15 or 1800 years. This is the entrance. You have to drive through this aqueduct to get to downtown Istanbul from the airport. So I'll just go back for a minute to talk about what preceded the Roman development of concrete and architecture. So I want to say a word about unit masonry, and I'm going to give you kind of a personal history of concrete, and I'm going to just hope there's no historians or engineers in the audience, because I'm making it up. So sort of. But the highest accomplishment in Greek architecture, it's really composed of stacking stones one on top of another. And so consequently, the spans that are allowed in unit masonry are very, very small. So even with this wonderful temple here in Priene in southern Turkey, you can see how close the columns are together. This architecture is limited by the biggest stone that you can put on top of these columns. It's only about probably a 15 or 20 foot span, and then you've got to figure out how to get the stone up there. So the Romans made this wonderful discovery that you could have a similar span, or maybe bigger, by using little units of masonry. You could use bricks or stones or rubble or anything. And as long as you stacked them in a way so that it was arched, and that arch stayed in compression, then it would be very stable and easy to work with. So my sense is that concrete construction really grows out of the logic of unit masonry construction. So if you think about the dome of the Pantheon, it's probably the most famous concrete building or unreinforced concrete building in the world with the biggest span. It's really an arch that's been spun 360 degrees. And because there's no steel in this, in order to control, the forces, the force pushing outward on the walls, the way that it was dealt with is that you can see that the walls get thicker as they go down. So as the forces increase from the top to the bottom, the walls get thicker. And then these ancillary rooms, the porch and the rooms that are on the side are really acting as kind of primitive buttresses. And then you also see the ribs, the concrete ribs and the coffers. The concrete ribs are kind of like beams, and then the coffers is the removed material that's not working structurally. So this led to an explosion of architectural form, which was realized beautifully in the mosques of the Ottoman Empire and in Gothic cathedrals and Renaissance churches. But all of that was accomplished in unit masonry, because after the decline of the Roman Empire, around 500, concrete went basically out of usage. Not completely, but there was about an 800-year period where there really wasn't much happening with concrete construction until the early mid-1800s in England. And this lighthouse is an example of that. And then by the late 1800s, early 1900s, there were warehouses and factories that were being made out of board-formed concrete. And Auguste Perret, a French architect and engineer, did this beautiful staircase and started to, well, he really defined a lot of the basic principles of concrete that we're still working with today. And he beautifully captured, the fluidity of concrete. I mean, the fact that concrete is really a liquid that is poured into forms. Le Corbusier took note of the industrial architecture of the period, and he transferred a lot of the techniques into domestic architecture. And we're really lucky here in San Francisco to have a great example of almost authentic Corbusian architecture. This is the San Francisco Art Institute. You see the Brise Soleil, which is a Le Corbusier signature. That is the shaded windows. And then there's this huge cantilever, concrete cantilever, which is an amphitheater. And the scuppers coming out of the courtyard above. This is a really amazing place with great indoor and outdoor space. And probably, I think, one of the best places in San Francisco to watch the Blue Angels. So I would encourage everybody to go to this place and really check out what a wonderful building this is. That building is by Pafford Keating Clay, who practiced here, I think, for a couple of decades in the 50s and 60s. So then there was Pierluigi Nervi, who really extended the language of concrete with cantilevers and warping thin shell structures. And I think he perfected the idea of the catenary arch and long span concrete. So it just gives you some idea of what concrete can actually do. The catenary is what happens if you were to hang a chain from 2 points, and the drape of that chain would describe the forces of gravity perfectly. And then if you were to translate that shape into concrete and turn it upside down and make an arch out of it, then that would be the most efficient structural shape that you could possibly have. And Nervi developed this idea, and you can see how thin and elegant his structures were. Again, we're very lucky to have a Nervi building here in San Francisco. This is looking up at St. Mary's Cathedral with the same idea as the Pantheon in a way, with the concrete ribs and the coffers. This building is at Geary and Goff, and if you haven't been inside, this is another incredible thing to see where you can really trace the lines of force. You can trace the forces that as they increase, they're carried down, and all the loads are carried into these glassy corners. So it's kind of a visual trick to take the biggest amount of the weight into the lightest part of the building, and then behind that glassy corner, there are these huge, beautifully sculptural pylons, faceted with board-formed concrete. And what's most amazing to me about the Nervi work is how primitively it was built, and I think this is where it starts to have relevance, for us. You can see that the forms are made by unskilled workers, and they basically cast concrete pans like these bathtubs, and they place them upside down on scaffolding, and then poured in between. They poured the concrete ribs in between. So what you're seeing here is this structure. It's the formwork of that. I'll go back for a second. So you can see the areas that are open and the areas that are capped. And so Nervi, he was Italian, obviously, and his buildings are often clad in travertine, just like the Romans, and obviously he must have known about the Pantheon quite well, and it has a lot of the same structural ideas translated into modern form. And he began to capture, the fact that efficient, structures, mimic the structures and the patterns of nature. So if you were to take that idea and maybe start to apply it more to the landscape, this is an erosion control structure captured by the Japanese photographer Toshio Shibata. It's made by draping steel reinforcing over the landscape, then it's sprayed on concrete, basically gunite, then grade beams on top of that to hold it all together, and then those bumps at each of the intersections are tiebacks where steel rods are drilled deep into the slope to hold it all together. So in areas where there's heavy rainfall and erosion is a serious problem, there's a whole language of concrete related to that, and this is the formwork for that same structure. So for me, thinking about landscape and concrete, it all comes back to understanding the basic idea of the arch. That is that concrete is incredibly strong in compression as long as you keep the weight on top and the sides are stable. Everything's good. If you push up, then it's working in tension and you need steel reinforcing to counteract that. If you took that arch and you turned it on its side, then you'd have Hetch-Hetchy Dam. And the water behind the dam, holds all that concrete in compression, and it's incredibly strong. So one of the great things about looking at infrastructure is that if you want to know what the future holds in terms of landscape construction, I think just like Le Corbusier looked at factories and warehouses and ships and planes to figure out what's the future language of architecture, if you look at infrastructure, I think you can start to figure out what is the future language of landscape. And there's nothing more strange and interesting and creative than the things that are being done, with infrastructure. This is all Hetch-Hetchy Dam during a big water year. So again, it just takes some observation to look at these things and try and figure them out. And it's for me, an endless source of creative ideas. This is some ancillary structures at Grand Coulee Dam. If you go to Grand Coulee Dam, most people have a look at the dam and take off. But if you really get off on some of the dirt roads and look around, you'll find some unbelievably interesting and odd things. So I just want to take a few minutes then and talk about a few of our projects. And admittedly, I'm showing these really grand and interesting projects, and then here we are working on urban landscapes. So in a way, we're taking this knowledge and we're miniaturizing it down almost to the level of furniture. And so I just wanted to give some examples of how we do that with an increasing level of complexity. So I'll start first just talking about some paving and benches. So this is the entrance to the Exploratorium on the Embarcadero, little entrance plaza. And we have about 2 acres of concrete paving out there, and originally it was conceived as being unit masonry. It was just going to be unit pavers. And we went through the inevitable process, and it turned out that we were going to have topping slabs, concrete slabs. So we did a lot of head scratching to figure out how to scale that concrete so it wouldn't just be overwhelmingly bleak. And we came up with this paving pattern which has 3 finishes of concrete, and this was actually designed by Wendy Mock from my office. And basically there's a smooth troweled concrete finish, there's a sandblast, and there's a broom finish. And then it's arranged in a pattern which is like a geometric abstraction of a shimmer, like the kind of shimmer that you would get from the surface of the water. Sometimes you don't see this pattern at all, depending on what the light is doing, and sometimes you can see it very strongly. And then with our benches, I think the struggle for us in working with concrete is always to figure out how to make it light. And we work with reveals quite a lot. We lift the concrete off the ground so that you have a shadow line. And these are pretty intricately formed blocks of concrete in order to get them to happen like this, and then to also kind of absorb the warping concrete paving underneath. So even when we're just doing a simple stair, like here at the College of Marin, we'll always try to get that shadow under the stair, something that Halpern did on all of his projects. It's been basically legislated out by code, but we managed to sneak in a little reveal there so we can get that shadow, and it still meets code. And this is just a little seat wall and a platform where students can sprawl out at this performing and fine arts complex. Students have critiques here, and these slots in the wall gather water from the plaza. And we were able to get a pretty reasonable quality of concrete on a community college project by controlling in our spec the type of formwork. So there's like cabinet grade wood used for the forms, and then the forms are built in a shop so that the curves are very, very precise. You can see the back of the plywood forms there. They're scored about every couple of inches so that the forms can be uniformly curved, and it's just probably the best clean curves that we've ever gotten. At Durant Hall at UC Berkeley, we worked on a new courtyard with smooth formed concrete. We worked on this with Mark Rogero. It's a historic restoration project, and what we did was we nailed plastic strips into the forms to make these reveals, and it's very precisely arranged. It's very modern detailing with very simple classical planning. And then we've done the opposite, where instead of nailing things into our forms and getting recesses, we actually remove some of the forms to get a protrusion. So you see these thin little lines is where two pieces of plywood comes together, and then we've beveled both pieces of plywood so that where they butt together you get a gap, and then the concrete oozes into that gap. We're always trying to remove concrete where it's not needed structurally to show its properties. This was kind of a tangle of stairs and handicap ramp and rails, and we use the concrete walls to try and make a sculptural place which might otherwise have been kind of a nasty little spot, and it's a little bit of an overlook for a sports field. 750 2nd Street. This is on 2nd Street, right near the ballpark. There's an 8-story building with I think 8 or 10 condominiums, or I think there's 16 condominiums. And in the back, there's a very tiny little garden, which is a stormwater management garden. And you can see how thin the concrete wall is here. To an engineer, a concrete wall is always 6 to 8 inches thick, usually 8 inches, so you have room for all the rebar and everything. And what we do sometimes is we'll taper those walls to a point so that we can get the concrete down to 2 or 3 inches of thickness. And then we textured the concrete here. We removed all the smooth cream from the surface to expose the sand and the aggregate, and to work with shadows, because shadows are free, and it really does a lot to help warm up the space. And so this is a bush hammering technique where literally every inch of those walls that you saw were hand ground with this tiny little tool, an inch at a time. This is a concrete stair for a residence in North Berkeley, cantilevered stair where we made a board formed wall and then drilled rebar into that wall and then cast the stairs around it. At UC Berkeley, we are just completing a substation, and that substation is basically a 2-story concrete box, and the inside wall is very smooth. It has, again, this cabinet grade wood, plywood, and on the outside a very rustic finish, which is made by placing 1x4 boards, I believe, with a 1/2 inch gap so that the concrete really oozes out between those gaps. And then when the forms are pulled off, which we found was very difficult to do, it breaks off these ridges in a kind of a random pattern, and we didn't do anything to alter the finish. We just let whatever happened happen. And at the bottom of this wall, you can see the holes in the wall in the area that's about to be buried. This building is, I like to think of it as the largest junction box in the world. Has all these conduits coming in, and this building provides power to the UC Berkeley new football stadium. And this is what it's looking like as it's finished. It's got painted metal louvers and some channel glass on the top and zinc walls and roof, and then the board form concrete. So that's how that's coming together right now. And because it's easy to make holes in concrete walls without disturbing its structural integrity, we cored holes and placed in them these cast glass cylinders so that people working in the control room inside would have some natural light. This is a house in Marin County. This is the wall the architects got. Smooth, beautiful wall, and this is the wall that we got. A wall that doesn't require any formwork at all. So if you're looking for cheap, I think this is what happens here is that, you know, there's tiebacks, steel rods that are drilled deep into the slope. I think they go back about 30 feet into the slope. Then a metal cage is attached to those tiebacks, and then the concrete is just sprayed on with a hose. And it's a very difficult finish to control, but I think it has a lot of potential, and I'm very interested to see somebody do something interesting with gunite. But we couldn't sell our client on that, so we just covered it with stucco, which was kind of a disappointment, but looks okay. And then I just want to show this very important project for me. It was finished more than 15 years ago. It was the first really significant project in my career, done with Dan Solomon, San Francisco architect, where there's a big curving roof on a chapel, and the chapel roof conducts the water down onto this big concrete gutter, and there's a huge poured concrete wall that supports the chapel roof, and in the foreground are tilt-up concrete walls for the mausolea at the cemetery around the chapel. So this is the big concrete gutter, cantilevered over these screens. And again, you can see these very thin concrete basins here. So again, these are like 8-inch thick concrete walls that taper to, you know, only 1.5 inches or 2 inches thick. And the wall that supports the roof is essentially a cantilever sticking up straight instead of hanging out horizontally, and it expresses its forces in that where the forces are greatest at the bottom, that's where the wall is thickest. So it's just a simple thing that can be done. Okay, and then I'm going to conclude just with a final anecdote about the Exploratorium. The Exploratorium is very much about removing concrete as well as pouring concrete. This is Pier 15 at the bottom. That's where the new museum is. Pier 17 at the top, that's the back of house area, and in the middle is a parking lot. So here you can see the parking lot, loading dock being removed, and whereas here you can see there's a very simple walkway around the outside. Here you see these 4 bumps outside the building, the 4 corners, that's concrete reinforcement that supports the building. So this is what we initially had envisioned, was these wide walkways with saltgrass plantings, and then this is what actually got built. So this is the value engineering version, and wherever you see these pilings that remain in the water, this is our future expansion area. And in the meantime, you know, it's improvisation area for the Exploratorium. So you can see what we still like to think of as a phase 2. Who knows if it'll ever happen? And this is what was completed. But one of the things that survived was this circular hole that's in the deck that you see over here. And what's going on here is that where you see these red rectangles, each one of those red rectangles is about a 6-foot by 6-foot concrete beam, and it's supported with those dots, which is a 6-foot diameter concrete column that goes down about 100 feet, and those are placed at the 4 corners of the pier to support the building. So that's the seismic reinforcement strategy. So you can see that we placed that circular hole right in the middle of one of those donuts, and what you're looking at here is looking down into that rectangle. Here you can see the column that goes down 100 feet. And this is the director of exhibits at the Exploratorium, Sean Lonnie. And he's lowering a dome-shaped mirror into this aperture to reflect up and to reveal what's going on underneath the pier so that you can see the seismic strategy. So I guess you could say this is our little version of the Pantheon, a little circular hole. It's also the logo for the Exploratorium. And you know, we just hope that all of you will continue to ask that Exploratorium question, you know, when you look at concrete, what's going on here, and just try and figure it out for yourself, because if you look at it, you know, it will reveal itself. Thank you. So I think Amy is going to